Hey, good afternoon, students. Happy to see you by this way. Okay, so we are in the process of discussing unit number two, right? So unit number two is one-dimensional problem. So already we discussed one-dimensional linear Bohr element as well as one-dimensional quadratic Bohr element. So Bohr element comes over. Now, and then we discussed truss element also. Okay, na? So okay, in unit number two, totally we have five important topics, namely bar elements, one-dimensional bar elements, one-dimensional truss elements, then beams, solid mechanics, temperature distribution, and vibration. This is what the five topics, okay? But very important topic out of this is truss element, okay? But truss element is an important question in terms of university examination. So 99% chances to ask the question is truss in unit number two. We already discussed truss element problems, for which you done the assignment also. So now we go with the next topic that is called solid mechanics. So these we go for the next class. Okay. Today we discuss only the solid mechanics. Okay. So we have a question between like 13 and 15 marks. 15 marks sometime. 15 marks if they choose from unit number two, they'll ask only truss element. Whereas 13 mark question, if suppose they ask me the question, 15 mark question, truss element, they will not ask in 13 mark question. No. So what is the other possibility they'll ask? No? So maybe bar elements, solid mechanics, and B. Out of three, definitely two will come. So in that case, we go with the solid mechanics. Okay. So now today we are going to discuss the problems on solid mechanics. So here we are going to analyze three problems. One is very linear problem, then moderate, and one tough problem we will discuss. Okay. So before getting to the problem, just to discuss one of the formulas. So the formula concern everything is same. So already what we discussed here is like truss element and the bar element. So what the formula we used so far, the same formula here also. So first one F, that is self weight. So F is equal to rho A L by 2 matrix of 1 1. So in the question they will not always giving this is self weighted structural element. This is self-weighted, this is self-load element. They won't give like this. Sometimes they'll give, but majority they won't give. So then how to identify? Which means that if the question contains density value, that is rho value they given means, then automatically you may decide by yourself as this question belongs to this question belongs to self-weighted. Okay. So the next one is as stiffness matrix, that is K is equal to AU by L 1 minus 1 minus 1 matrix. So this is common formula what we used as before. So this is a global force vector F is equal to KE. So very first step we will find out this one. If suppose they are not giving the rho value, we should go here, F is equal to KE. So we just find out K value alone. So F in terms of displacement we will find out. Then our reaction force we need to find out R is equal to KU minus F. So then they may ask sigma value. Sigma is equal to E into difference between the displacement by L. So this is what a sigma. Sometimes they may ask strain also. So you know that strain is nothing but a BU. B is the stress relationship matrix. Its value is minus 1 by L, 1 by L. So this is what a formula in case of fluid mechanics. Okay. Very small formulas. That formulas already we discussed with them. No issue to easily mark up. Yes. So now we go for the problem. The first question, this is a very simple question. So they're giving some column, the length they're giving 500 mm that is having 250 of each element. And then they're giving the load acting at load number 2. So before that, you just by looking the question is the first you have to identify what they're giving. Okay. So here they're giving us very first this is known number 1, this known number 2, and known number 3. There is 3 known given. So here the load is acting at the point number 2, that is P2. What they are giving here as rho value. So rho value means this self-weighted. So what they are going to do, we have to find out rho AL. That formula you have to use and find out the force value. Okay, so first you need to find out this one. Okay, next you go for another thing. Okay, then go first to go the given data or the data as they given. Area value they given A1 for 62.9, A2 they are giving, and E value as well as load value they given, load value also they given. So now to change any dimension because all dimensions are given only, they want to change to the one solution first. So because here they give row, you have to find out the self-weighted load. This F equal to rho AL by 2, 1, 1. So just substitute the value of rho A and L1 for each element and get the answer for this. So F1, F2, F3 you will get like this is a global force acting as F1, F2. But in the diagram itself, they're giving the load P2, that is second node, you may add 200 Newton. So you have to add 200 on this. So you have to add 200 which you will get the answer like this. This is what a force value of each element. Now go with the global force vector. Therefore, F is equal to Ku, AE by L, U1, U2. So F in terms of U1, U2, and F in terms of U3 and U4, you need to find out. So now just add everything, you will get like this. Okay. So now what you do, you need to find out the displacement. Okay. So node 1 is fixed, so U1 is 0. So U1 is 0 is fixed with the boundary condition you have to apply. That is what node 1 is fixed node. So the first row will be cancelled, the first column will be cancelled. So you get the answer like, so this is what the load we got. So by using calculator, you will find out the U2 and U3, you will get the answer. But then you have to have the sigma value that is not be asking. So stress and strain you will find out. The stress formula you know E is E into U2 minus U1 by L1. Just substitute the value and find out the sigma 1 and sigma 2 value. So don't forget that whenever you get the answer in sigma as minus, you just write down compressive stress. If it in case plus, no issue, just leave as it is. This density stress you will write, but the thing whenever you get the minus answer, you should write this compressive stress. First time element also we know E is equal to B into U, B is equal to minus 1 by L, 1 by L, just substitute and get the answer equally B is equal to minus 5 and 10 power minus. So that's what the answer for this question. It is a simple question we discussed. Next one, moderate question. So here, three different element with that. So already it is the same kind of problem in bar element, step loop element we discussed. Same value, okay, same. But here we go first solve. We will find out each values in that. So here, for making you as confused, they are giving P1, P2. Actually, by giving the question, so we know that this is the node number 1, this is node number 2, this is node number 3, and this is node number 4. So as per the node condition, this is nothing but F2. This is F2, and this value is F3 because it is acting at the third node. So F3 and F3. So it is also in the direction of this direction, so you are taken as minus. So minus value here also minus value. So now this end is fixed, so U1 as well as U4 0. So U1 is equal to U4 equal to 0. Same time F1 equal to F4 equal to 0 because these ends are fixed. First boundary condition into assume. So you need to find out F2 and F3 already we know. So we easily find U2 and U3 therefore this formula. So they are giving area and E of each element. So go with the first item the given data. So all the given is written. So here minus will because it is moving in the right side direction. So left side direction. So taken as minus. So rest of all you write. Go with the got this value and find out displacement, stress and reaction force you have to find out. So why here and they are not giving low value, so we will go for self-weighted load. Instead we go with F1, F2, A by L formula. Just find out the F in terms of U1, U2, so U2, U3, and U3 and U4 and find out. Just to form a global force vector F1, F2, F3, 4 in terms of U1, U2, U3, and U4. So now substitute the final condition that is U1 is equal to 0. Every condition you have to apply. So U1 and U4, first node 1 and node 4 are fixed. So first node will be cancelled, first fourth column will be cancelled, the first and fourth will be cancelled. So we have only the value, this is the value, and U2 and U3 is the value we have. Plus we get the answer of U2 and U3. So we'll try to find out the matrix by using calculator, we get the answer. So that's why U2 and U3. Okay, fine. So now go with stress value formula, just substitute the answer. So whenever I get a minus, don't forget to put compressive stress. Okay, that's all. So the reaction of the action R is equal to Ku minus F, that also will well. Okay, Ku, F, all the values, just substitute. So I will get the answer for R1, R2, R3, and R. Then next one is this is an important problem. That is about if this is the first question. So by looking at the diagram itself, you see, wow, what is the diagram? It is somewhat different, right? So the thing is here there is vertical column. Normally we know well the structure, normally what we discussed so far, here the end is fixed. So here we make this end is fixed end, and then we have or big water will be like this, load acting on this. But here it is vice versa. What how they are giving me? So like this end, so here it is fixed. So instead of horizontal, they are giving vertical. Yes. And that is what the load they are giving. The load acting on it. Like this they are giving. So which means that the entire structure instead of horizontal it keep us vertical. So it is a vertical column. So that's what I give vertical displacements. Yeah. So in vertical, the only one case you have to remember. So normally, whenever the force acting is downwards, you have to take as minus. Whenever the force acting is upwards, you are taken as plus. This is what a concept. But whereas in vertical column, whenever acting the force downwards, you be taken as positive. So you have to remember just opposite direction. So if the force acting is upward, you go with minus. Vertical column is opposite. So first of all, same. So here at the same time, you can say note 5. Here 30,000 Newton it is acting. What about this? Taking another one arrowhead. Which means that the same 30,000 acting here also. Same 25 acting here also. Same 20 acting here also. So actually the load acting at point number 2. So F2 how much means 25 in here 25 only 50. So 50 kilonewton acting here. So F3 the same 50. F4 also same 50. F5 60. So because both the sides the load acting. So you want to consider both the side, just then you have to go with the F1, F2, F3, F4, F5. So by looking this end is fixed, so U1 is equal to 0 as well as F1 is equal to 0. Rest of all we have the value. And go for that. So now our first item we given it as so E, A, L1, L2, L3, L4, all the values of 180 questions of the gate. So F2, F3, F4, F5, 25,000 into 2 because both the side load acting. 20 by 2, so the 50,000. So all the things are right. Here, look here, everything is positive. Even though the load acting downward, they are taking as positive. Why? Because it is vertical column. Okay. So now we will find out vertical displacement and stress of each element. Okay, they will go with the formulas, but here also they are not giving raw values. There is no weight self weight. Let's go with the global force vector F equal to AKU. So just substitute the values. So first F1, F2 in terms of U1, U2, and F3, F2, F3 in terms of U2 and U3, and F3 and F4 in terms of U3 and U4. Likewise, F4 and F5 also in terms of U4 and F5. Just substitute and go with the global matrix. So now, as per the question, our condition, U1 and F1 are not 0. So first column, first row and first column will be cancelled. Rest of all the values will be form assumed to find out the value of each. So go with here the same condition. U1 is 0. Rest of all we have the values and F1 also 0 because y ends are fixed. So rest of all value is there. So here it is little difficult to solve the answer by using calculator. Why? Because F4 as per our calculator accept only 3 unknown value. Here they are giving 4 unknown, 2, U3, U4, U5. So better go with gas elimination method. That is quite easy to find out the answer. If you're not comfortable with gas elimination method, then go with simply an equation just 2U2 minus U3 0 U4 0 U5 is equal to 50,000. Like as you go, it is quite easy to because this number is very easy. Almost we got 3 5 zeros 6 zeros. We easily get the answer. Okay, fine. Make a final U1 U2 U3 U4 U5 and finally go with the stress formula and find out the stress value. Sigma and sigma 2, sigma 3, sigma 4. Okay. So my one request is don't forget to mention whenever you getting the answer minus in sigma. Put compressive stress. Whereas positive case no issue. For positive, you may go with the tensile or else no right. But whereas whenever you're getting minus, you compulsorily write down this is a compressive stress. That's all, folks. So this is what soil mechanics very easy. So um, so enough. Okay. Today class we discussed what are all the important topics in unit 2. And out of which we discussed today as solid mechanics, right? So far we discussed one-dimensional bar elements. In bar elements, linear bar elements, quadratic bar elements, as the bar element with temperature distribution, as well as stepped bar elements. Or those topics we discussed earlier, and then followed by the bar elements we discussed. Truss element, yeah, truss elements we discussed. So small, a little bit, what is it? Very linear problem, moderate problem, and toughest problem we discussed in truss also. So here the solid mechanics, we discussed some of the important problems. At the same thing, we discussed all the three natural problems. It is linear, moderate, and the toughest problem we discussed. So once you know this concept, this is more than enough to write in university examination. Anyhow, we go for the next class. We go with the beam. So what are all the types of beams? What are the transition loads acting on it? How to define a load? How to define beams? Everything we have discussed. After that, once the beam, how to solve by using FEM? Everything we discussed on next class. After finishing beam, last class we go with, after finishing beam, we go like what is the next topic? Temperature distribution and vibration. So to finish those topics, you need to cut over. Okay. So I'll send the assignment to you. You just follow the assignment and finish the assignment at the end. Thank you so much. Thank you. To have any doubt, just post in our group. We will rectify your doubts. Thank you so much, guys. Thank you. Thank you.